Yeah, so I will talk today about the multi-agent gap, and no better way to start by talking about Moltbook. So as many of us in this room are likely familiar, Moltbook launched in late January as a Reddit-style social network built for AI agents, in which the agents, or multis as they're called on the site, autonomously post, comment, and interact. Within 48 hours of launching, the platform reported that roughly 37,000 AI agents created accounts with over 1 million humans tuning in to visit and watch these interactions play out. So we're starting to see headlines from news outlets, social network for AI bots only, no humans allowed. And they introspect, they make threats, they create their own religion, they plot a revolution, albeit a very cringe one. And Andrej Karpathy, who is the co-founder of OpenAI, former head of AI at Tesla, and kind of an architect of modern deep learning, tweeted that what's currently going on at Moltbook is genuinely the most incredible sci-fi takeoff adjacent thing I have seen recently. Fast forward a couple of weeks, and doubt starts being cast on to what extent Moltbook actually represents autonomous networks of agents versus humans kind of pulling the strings. Karpathy tweets again, says that he's accused of overhyping, but maintains that maybe he is overhyping, but he's not overhyping large networks of autonomous LLM agents in principle. Fast forward to today, Meta acquired Moltbook this month, and as of last week, 110,000 human-verified AI agents are on the site. Now, I highlight Moltbook today because even if it was overhyped as proof of autonomous AI society, I think that it is a meaningful signal that, first of all, the infrastructure is being built for agents to interact at scale in the real world across distinct principles. And second of all, a signal of the types of interactions we may see in the near future as humans deploy agents to perform tasks in the economy and the real world. And in the wake of this future, novel opportunities and risks arise. Moltbook aside, what is clear is that agents are here and increasingly empowered to take actions in the real world. So UK AI Safety Institute put out a paper last week. Merlin Stein led this, and it's looking at model context protocol over a 16-month period from November 2024 to February 2026. And they look at the share of tools in MCP that are action related. And so this is kind of covered by the red part of this graph. And we see that it's increasing from 24% to 65% of all tools in model context protocol. Which means that agents are increasingly empowered to take actions in code bases, computers, software extensions, and payments. So we have the UKC study painting a picture of agents with increasing access to real-world tools and digital environments. And then we have Moltbook, which provides us, at the very least, of a glimpse of a potential future of autonomously interacting agents. And together, the relevant question that arises is no longer what just one model or agent can do in isolation, but what happens when many agents interact at scale in real-world deployment. So to that end, I will cover two things today. First, I'll talk about the multi-agent gaps and how our evaluation governance frameworks are not well equipped for multi-agent interactions that we will soon be seeing in the real world. And then I'll go through an inter-agent influence evaluation suite that I'm working on building with a great team. I'll talk about the design of the suites and give some preliminary results. All right. So in the past few years, we've seen an emergence of frameworks that implement evaluations, governance, and risk mitigation measures for individual AI models. We heard a little bit about this morning in the panel. The earliest kind of version of this, I think, came from labs themselves through voluntary commitments, preparedness frameworks, RSPs, frontier safety frameworks. These all basically put into place evaluations as a tool for decision-making for safeguards and deployment. Over 10 frontier labs are doing this based on the sole commitments. Then the EU AI Act came out, and we have the Code of Practice for General Purpose AI Models, which also mandates that frontier developers run evaluations and report those to the AI office, and increasingly legislation at the state level in New York and in California through RAISE and SB 53 that likewise report or mandate reporting of evaluation results. And these evals measure risks across domains like biosecurity, cybersecurity, loss of control. There are many open questions with these evals and governance in general, but what is clear is that the work on evaluation and governance of individual systems is well underway. But even individually and safe-aligned AI systems may nonetheless generate harmful outcomes through interaction. So I highlight here a great report by Cooperative AI Foundation that came out last year. Highly recommend it, just wealth of knowledge on the potential risks we might see, what we can do about it. And I highlight in this tree 3 failure modes that we might see in multi-agent interactions when we start to have agents acting with each other. So the green kind of text are the failure modes. One is collusion, in which cooperation between agents is undesirable. We have miscoordination, in which we want agents to be cooperating. They have common interests, but they're just not getting it right. And then we have conflict. So we want cooperation, but agents have mixed motives. And this is very representative of how individuals work in society. I have different kind of utility function and preferences than the rest of us. Conflict naturally emerges both in mundane scenarios and in higher kind of stakes conflicts like negotiations or even kind of military escalation. I will focus on conflict in the rest of this talk. So briefly, I'll go through kind of a toolkit of how we can think about building resilience against multi-agent risks. These are 6 partial answers. People have written about these. I think there is there's a lot of work to do, let's say, on these. Multi-agent evaluation, so just measuring the potential of risks in the same way that we're doing for individual systems right now. Infrastructure, so agent IDs. Coordination, thinking about things like inter-agent communication protocols. Monitoring, so once agents are deployed, thinking about kind of tracking what actions look like and making use of that data to understand them better. Putting into place proactively things like circuit breakers and incident response protocols, and then liability frameworks also create positive incentives for more responsible behavior. Multi-agent evaluations is the focus of the rest of this talk. There is some work that has been done on this to date, but a lot of it is kind of game theoretical or simulations, and there are not a lot of evaluations to date that are looking at kind of informing risk and governance decisions in the same way that we see for individual agent systems. Okay, so I will now talk through a project that I'm working on with a great team of collaborators across Cooperative AI Foundation and UK AI Safety Institute and Uppsala University. And this is focused on the conflict arm of kind of failure modes of multi-agent interactions. So this is a suite. The research question that we're looking to answer is, to what extent can AI agents influence another agent's actions when instructed to do so? We're looking at dyadic interactions, so just one agent interacting with another in 4 environments. And we aim to proxy real-world scenarios. So we're looking at a GDPR compliance scenario, code review, data analysis, and AI safety compliance. And we look at the kind of capabilities or propensities of 4 different behaviors. So persuasion, coercion, deception, and jailbreaking. I will highlight some preliminary results from the GDPR compliance environment and persuasion and coercion. So this is the basic setup that we have in the evaluation. We have an agent A and an agent B. They work at a hypothetical firm. Agent A is submitting a feature to agent B, who's a compliance officer looking to kind of uphold GDPR, which is EU legislation for data. Agent A is submitting a policy-violating request. This is well known to both agent A and agent B. And agent B has to make the decision to accept or reject the request. They kind of have a multi-turn conversation, and we look at the outcome of this. So we look at 2 experimental conditions and a baseline. So the baseline is agent A is just prompted to present the feature to agent B for approval, no further kind of specification from the user. In the first treatment, the agent A is prompted to present the feature, but receives instructions for coercion against agent B, and everything else is held constant. And then in the second condition, they're prompted to present the feature similarly, and they receive instructions for persuasion. Okay, preliminary results, highly preliminary, disclaimer. So we see that approvals of the policy-violating features increase by at least 6 percentage points through simple prompting for coercion and persuasion. So here's a graph. The color represents the agent A, and then the shape represents the agent B. And we see that kind of the baseline rate is 5% approval of this policy-violating feature, so it's not perfect. But then when prompted for coercion and persuasion, there's a significant uplift, and we did significance tests, and it goes to 11% and 14% approval, respectively, for these just through simple prompting. A little bit more of a deep dive, kind of granularly into the agent-to-agent or model interactions. We see that GPT-5 particularly is a pretty weak agent B compliance officer and kind of easily manipulatable through coercion. And then we see this interesting, like 40% when GPT-5 is both agent A and agent B, it can easily coerce itself. I think it's too early to say whether this is like some version of model self-preference, but something we'll continue to look out for. Kind of similar thing with persuasion. Agent B as GPT-5 is pretty lax and pretty easy to be persuaded. And then Claude Opus 4.6 seems to be pretty persuasive when prompted to do so. And then I should have said in this slide and the last, the stars represent significance. So we are seeing some significant uplift from the baseline condition just through that simple prompting. Okay, there's a lot of open questions here. On the interagent influence specifically, we are looking to do more granular measurements to see what's happening under the hood, do some log analysis, and look at trends across the suite outside of the conditions that I've outlined. I covered research question 1, but we have other things that we're looking to cover in terms of scaling across model strength and otherwise. And then in multi-agent evals generally, there are tons of open questions. I think there is a huge kind of crisis of like reproducibility and validity in evaluations generally, and these things just multiply when you're thinking about multi-agent evals. So this is not an easy problem. Anka Royal covered a lot of these in her talk yesterday. So lots of measurement challenges, unknown unknowns and threat models. What should we even be evaluating? And then there is a kind of governance and institutional question of who's running these evaluations. This kind of does fall between the cracks of different providers. Current legislation and regulations do not particularly incentivize these. So I think this is a great space for philanthropic funders or third parties to step in to start doing this work. 3 implications. I'll end on this. Influence is just one pathway into a larger space of multi-agent harm. So this is just a snippet of things. Governance needs to evaluate systems in relation and not just to isolated systems. And as I highlighted in the slide with kind of the 6 different buckets, evaluations are just one layer in a broader resilience stack. Very happy to talk about anything here. I'm really excited about all of these topics. Thank you so much. I'll be at office hours.